Okay, let's look at a test that helps us graph functions. Okay, so take a second to pause the video and write this down. Okay, so if you have a critical number, we can say that one of three things is happening. Either we have part A, that's a possibility. Your function is increasing before the critical number and decreasing after. Okay, so your function is doing something like this, increasing, then decreasing. So we have a local max. Let's rewrite that. Let's say f of c is a local max. The next one, part B, you have a function that's decreasing, flat, and then increasing afterwards. So right there, you have a local min. Part C is when is just to warn you that you could have nothing. You could have increasing. Oops, it's not very good. Increasing, flat right there, and then increasing again, right? That's a possibility. So in this case, f of c is neither max nor min. Okay, so that's our what's called with first derivative test. Sensible. So we can use that and just that to do some sketching. It's kind of our first new tool here in calculus. So example, find the relative extrema. So I'm saying local maxes and mins of f of x is equal to x cubed minus 27x. And also sketch afterwards. All right, so let's do this. So if I'm looking for local max, local min, I should find critical numbers. So f prime is 3x squared minus 27. To find critical numbers, I ask when is that derivative equal to 0? Well, I get 3x squared minus 9 is equal to 0. So x is equal to plus or minus 3. So here's two critical numbers. F prime does not exist? Never. Okay, in this case, we have a polynomial. F prime will always exist for any x value. So what we're going to do is we're going to take these critical numbers and we're going to put them on a number line, minus 3 and 3. And we're going to decide when is the function increasing and decreasing. So we're going to use f prime to do that. So we're going to factor f prime even more. It's x minus 3 x plus 3. So using test points, okay, f of minus 4 gives me 3 times, well, a negative number times, times another negative number, right? Which is greater than, which gives me a positive number. Sorry, that's f prime right there. So I plug negative 4 into my derivative, gave me a positive number, which tells me that I'm increasing here. Then for the middle interval, I would try 0. Now I get 3 times a negative number times a positive number, giving me a negative number, so I'm decreasing in that middle interval. And finally, f prime of 4 is 3 times positive times positive. So double, so all positives, so get a plus there. And so my function is increasing here. Okay, so the question was find the critical numbers and then sketch. Found my critical numbers right here. I got plus or minus 3. And then with this number line, I'm going to build a sketch. So what can I say? From the number line, I can say that I have a local max here. And I have a local min here. So I know when x is 3, there is a local min, but I need to find the corresponding y value. So I'm going to take 3 and plug it into my original function f. Okay, f of 3 is, it was cubed minus 27x, right? If I'm not mistaken. X cubed minus 27. Let me just double check that. X cubed. Yep. Okay, where was I? Scrolling like, okay. So I get 81 minus 81, which is 0. Okay, so local min at x is 3, y is 0. Now if I take negative 3 over here, f of negative 3, what do you get? Negative 3 cubed minus 27 times minus 3. 81, oh, I made a mistake, didn't I? I'll fix that in a second. Minus 27 plus 81, which is 54? 54. Yeah. Okay, sorry, I made a mistake over here. What did I do wrong? Calculation error, it's 27 minus 81. So I shouldn't have 0 here, I should have negative 54. All right. So when I plug negative 3 into my original function, I get 54. So that is a local max at the point minus 3, 54. Okay, so these two things together allow me to make a little sketch. Let's see. very basic sketch. Do it in blue. And my function is f of x is equal to x cubed minus 27x. Okay, so when I plug in 0, I get 0. Just when you're sketching, little table values can't hurt. So when I plug in 0, I get 0. So when I plug in 0 here, I get 0. So it goes through 0, 0. And then it goes through 3, and we'll say negative 54. Say this is positive 54 up here. Say this is 3, negative 54. Okay, one thing to notice here is I'm choosing my scale based on these points I found. Okay, so don't go and pick a scale until you have a sense of what points you're actually going to be plotting. Okay, my local min at 3, negative 54. That's my dot in the bottom right. And then local max at negative 354. That's my local max. So I got a max. So negative 354. There's a max there. So you can draw a little hill there. And a min at 3, negative 54. So I can draw a little valley there, right? And for now, I'm just going to connect the dots, in a reasonable way. So how do I know? How do I know How do I know something weird isn't happening? How do I know something like this is not happening? How do I know? Well, if it were doing this, well, that would be another max, right? And I would have found that already, but I did not find it. Okay, so it tells me that this curve just has to continue on the way it's going. You can't change direction. And likewise over here. Okay, so here's my rough sketch of F.